Hi, this is Miss McKay, and today we're going to talk about the triangle inequality theorem. The triangle inequality theorem is defined as a triangle exists if the sum of the two smallest sides is larger than the third side. Okay, so that's the point of the triangle inequality theorem. I'm going to be doing 4 examples today, and the first thing that we're going to do is from the 4 examples, we're going to determine if the following side lengths could form a triangle. Prove your answer with an inequality. Okay, so if you want to know if a triangle is a triangle, usually a triangle let's see, a triangle has 3 sides, and usually you have uh, side lengths. If it is a triangle, when you add 2 of the sides together, they should be bigger than the third side. If they're not, then you have a triangle that doesn't meet all the way. That means you're going to have a third side that's going to be shorter than the 2 sides added together. So that's the concept of triangle inequality. So looking at our first example, we got determine if the following side lengths conform. Try to prove your answer with the inequality. So we're going to start with the 3 sides that we're looking at here is 8, 17, and 24. Now, normally you would test all 3 sides, like 8 plus 17, then 17 plus 24, and then 8 plus 24. But the quickest and easiest way to do it is to add together the 2 smallest sides. So first I will identify the 2 smallest numbers, which is 8 and 17, and then I will add them together. 8 plus 17, and you're checking to see if it's greater than 24. Okay, so 8 plus 17 is actually 25. And is 25 greater than 24? Yes, it is. That's a true statement. And if it is true, that means that this is a triangle. So you would say, yes, this is a triangle. All right. So let's try our next example. Our next example is the side lengths of a triangle are 25, 35, and 12. Now again, we're going to go with the 2 smallest lengths. All right, so we're going to go with 12 and 25, and we're going to add them together, 12 plus 25, and we're going to see if it's greater than 35, because you're adding the 2 small ones to see if it's bigger than the third side. So 12 plus 37, 12 plus 25 is 37, and 37 is larger than 35. That's also a true statement. And yes, this is a triangle. Okay, so I'm going to go to example 3. Example 3, all right, is 3, 3, and 7. Those are our side lengths, 3, 3, and 7. So we're going to underline or identify our 2 smallest sides, which is 3 and 3. And then we're going to add them together, 3 plus 3, and we're going to see if it's bigger than 7. 3 plus 3 is 6. 6 is not bigger than 7. So this is a no. It's a false statement. So um, actually, let me say this instead. Let me say false because this is a false statement. So the answer would be no. This is not a triangle. Basically, you're having a triangle here where you got 7, 3, and 3. They don't meet, because when you add the 2 smaller sides together, it has to be bigger than the third side. And since they're not, it means it's a triangle that doesn't form a full triangle. Okay. For our fourth example, we got 28, 50, and 22. So we're going to identify two smallest angles, which is, smallest sides, so 28 and 22. And then we're going to do 22 plus 28, see if it's greater than 50. 22 plus 28 is 50, greater than 50. Now you can't have 50 greater than 50. It either has to be 51, 52 has to be a number bigger than 50. So this is a false statement. And this is no, this is not a triangle. Again, a triangle would kind of look something like this, um, where it's like 20, 22, 28, and like 50. That's what that means when they're saying triangle inequality. All right. Those are our examples on the triangle inequality theorem, how to determine if a figure is a triangle.